Good morning. Today we're going to solve systems of equations by the elimination method. We're on page 7. Page 7. Systems of equations, the elimination method. Some people call this the addition method. Same thing. We're going to start with number 1 because this explains very well what you do in these steps. I love these. All right, here we go. So again, you know, 2 or more equations that you're going to graph on the same line are called a system, and where those lines cross is the solution to the system. Now, this first one is a really good example to use because it'll help me explain what this is supposed to look like in order to solve it. So in the elimination method or the addition method, you need to have these stacked on top of each other, like the x's on top of the x's and the y's, the equal sign and the constants. They don't have to be in these particular places, but they need to be stacked with each other. Y'all see? Now, the whole idea, this is called the addition method because what we're going to do is just add straight down. Just add straight down, but it's a really big but. You have to have it arranged so that one of the variables will come out to 0 and cancel out. In this case, it happens to be the y's. Notice that if the numbers are the same and the signs are opposite, they will add up to 0, and you can ignore this now. Now we're going to add straight down, and we have 8 x's equal 32. Y'all see? Any problems there? I want to go slow.
Yeah, could you explain that one more time? How is that 32?
Okay, these are the 2 equations that they give you, and we check to see if they're stacked, and then we check to see when we add if one of the variables will fall out. And we saw, I'm sorry?
What do you mean by that?
Add up to be 0.
How would you add all that up to 0?
Well, if you have 5 y's in this hand, y. If you have 5 of them here, and then you take away 5 of them, how many do you have in your hand? You have 0, right? Gotcha. So that's how I know, is if you have a certain, I'm sorry,
32.
I added 20 plus 12. I'm adding everything straight down. And 20 plus 12 is 32.
Okay, but what?
Go ahead.
No, I'll see when you do it.
No, move your hand and talk to me.
I don't like to move. But no, I get you're saying you added the answer. Why did you add the answer though instead of? Because it's already figured out, right? So what are we trying to get?
We're trying to get this. We're trying to get a point with an x coordinate and a y coordinate that would be the point of intersection with 2 lines. We need that point. That's the solution of the system. Okay? So that's what we're trying to do, is find the point where these 2 lines, if I graphed them, where these 2 lines would intersect right there. That's the solution of this system. That's what I'm trying to find. So right here, if I go ahead and solve for x, I need to divide by 8, and so x is going to equal 4. You guys okay?
Miss Deborah.
Yes.
What are we doing? Are we doing the point slope form?
No, we are on solving systems.
Oh.
Okay, that same packet we were on the last time we saw each other. It says systems of equations.
Okay, what page are you on?
7, page 7, is that correct, guys? Page 7. We're solving by the elimination method.
Okay.
So the X information that we found was X equals 4. But if you notice, the point of intersection has 2 coordinates. So I still need to find out what Y is equal to. So what I do is I take the value of X that I already know and plug it into either one of these. Does not matter which one. So I'm going to take the top one. 2 times X is 4 now, plus 5Y equals 20. And I'm going to solve for Y. So I have 8 plus 5Y equals 20. And I'm going to subtract 8. Surely I didn't make a mistake again. And then 12 divided by 5. So Y equals 12/5 or 2.4. Looking on the back, please tell me I did okay. Yay. So Y is 12/5.
Wait, so you just added those both together and that's X? Is that what you said? No. You added the answer to both of those together and then you divided it and then that's X.
And then that was X, yes.
Where did you get the 8?
I took 2 times 4.
2 times 4. Oh, duh, because it's in the,
Parentheses, so it means multiply.
okay.
Yes. Questions, Sherry, Doris? I'll do some more of these. This is new.
I'm good.
You're okay?
Yes.
Sherry, you're just watching for a minute?
Yes, I'm trying to figure it out.
Okay, you'll be in on the first part of this now, the next one.
So we're actually, so the second part, we're doing the 5/5.
Yes, where you divide to get rid of the 5. Yes. You mean right here?
Oh, so it'll actually just still be the same as 0, but it's just not gonna be,
It's the same as 1 because they're divided. Something divided by itself is 1. Yes? Let's do another one. That's the first time. So before I erase this, I want to go through the steps again. If you're going to use the addition method, you want all the pieces on top of the same variable. You want them on top of each other. And the second thing that you have to have is a negative and a positive of the same number in order to add those and get 0. You have to zero out a variable. The rest of the part is really easy.
So is this the kind of type of problem where it's not gonna have like different steps like the other ones you were doing, like every question you had to like literally figure it out. It wasn't just that.
It won't have as many. That's why I like this one.
So this one's just lining them up, adding the answer together, replacing that answer for X once it's simplified.
Yes, yes, yes.
And then just doing that.
You have the outline.
and one of
Wonderful.
those has to be a 0.
One of them has to zero out in the very beginning. Let's do another one. I'm going to do another one where they zero out pretty easy. And then I want to show you probably what you'll see more often where it isn't set up for you. You have to make it happen. Okay. So the next one I want to do will be, let's do number 4. No, actually, I want to go ahead and do number 2. All right. Let's do number 2. Okay, this is a system and I want to solve it by the addition or elimination method. And the first step that I told you that we have to have is the things stacked on top of each other. So the P's are okay, the Q's are okay, and the constants are okay. Everybody's where they belong. Now I'm going to decide what variable I want to get rid of. And it looks like the easiest one would be the Q's. But look closer. These are not going to zero each other out. Do they add? Both of them are positive, right?
Mhm.
And we said the numbers have to be the same and the signs have to be opposite. What am I going to do? So all I have to do is take this into my own hands now, and I'm going to make this be a negative. Now, I can't just write a negative. You can't do that, you know. Maybe, but let's do this. Let's multiply the bottom one times negative, yes, ma'am.
So if you want to make it a negative, can't you just, would it come out to the same answer if you took the negative from the 15 and you took the 4?
I didn't hear the last part because your hand's in the way.
If you, would you get the same answer if you took the negative away from 15 and put it in front of the 4?
That's kind of what we're going to do. But you have to be real careful and do something that's legal in mathematics. So what we're going to do, if I need to think, okay, all I'm trying to do is get this to be a negative. And the way that you make that happen is you're going to have to multiply the entire equation by a -1. Now we're going to use the distributive property here. And this is what I do when we have to change something. So I have the same problem over here and not a big mess. So the top equation, I didn't do anything to it. So I have 3p plus 4q equals -3, making sure that's still on the screen. Okay. And then I changed this one. Don't put equal signs here. Put an arrow so things don't get mixed up. So a -1 times a -1, -1 times a -1 is a +1, right? So 1p, stop me when you get confused. So now we have a -1 times a +4. -1 times a +4 is a -4q equals, and one more time, a -1 times a -15 is a +15. Since I have taken that -1 through the whole equation, then this is the same problem, but it looks different. So now what I have accomplished is I have my Q's are the same numbers, but opposite signs. Do y'all see? So now a +4 Q's in my hand and I take away 4 Q's, that's 0. And that's what I wanted to happen. Sometimes you'll have to change the original by taking it times some value. So this is the problem we're going to work now. I have 3 P's plus another P. So I have 4 P's equal -3 plus 15 is a +12. I want to solve for P. So I'm going to divide by 4 on both sides. 4 divided by 4 is 1. 12 divided by 4 is 3. So we have 1p is equal to 3. Now remember, pardon?
How did you get the -4? -1.
-1 times a positive. Negative times a positive is a negative.
Okay. That's not
The rule?
no. Is that the same as like positive and negatives? 2 positives make a negative?
2 positives make a positive.
Yeah,
Two
positives
negatives make a positive.
Is that the same thing right there?
If the signs are different, then it's negative. If the signs
I
are,
thought that's the sign you go by the biggest number.
That's in addition and subtraction. Multiply and divide are totally different rules.
That's right.
Negatives and positives, there's a whole handout.
Yep.
Okay. All right, we found out that the value of P in this system is 3, but remember, the solution of a system are 2 coordinates that equal 1 point. Now we're dealing with P's and Q's instead of X's and Y's, so you have to put them in alphabetical order. P will come first, and then the Q, we know the P is 3, which leaves us to know that we still have to solve for Q. We can take our P value and put it wherever we want to up here, either one of these. It doesn't matter. So since neither one of them looks easier than the other, I'm just going to go for the first one. So 3, and this P now is equal to a positive 3. When I put it in parentheses like this, it means multiply, plus 4Q equals negative 3. So now I have 9 plus 4Q equals negative 3. I'm solving for Q, so I have to take away 9. I have 4Q equals negative 12. Solving for Q, I need to divide by 4. Divide by 4. So I found out that Q has to equal a negative 3. And that's my other part of this coordinate point. So the place where these 2 lines would cross if we graphed them would be at this point. Questions? This will turn out to be a little bit longer today, but I really do want to do 2 more to explain these to you, okay? Now going back as a review, if the only thing I want to do is change a sign, that's all I need to do, then just multiply by a negative 1, and that will change the sign, okay? But sometimes we need to do more than just changing a sign. Anybody still need this from the board? Speak up. All right. Maybe go to page 8, possibly. Now I've explained most of those. Let's go to page 9. Well, maybe not. They didn't give you any of the ones I'm talking about right now, so we're not going to do that. Yeah. Okay, look at page 7, 8, and 9 and find any other one that you want me to help you for an example. I'll work it.
I just have a question for A, where it says M plus N 8, 3, number page 8, number 3, M and that's the invisible ones, right?
Those are the invisible ones, so just, it'll help a lot if you'll put the ones in front of it, Christina.
For number 3, can't you just look at it and like, can't you just say like 6 plus 3 is 9? And this number minus the dimension.
But then if you said 6 plus 3 is 9, then you have to use the same 6 and 3 on the other one, and 6 minus 3 doesn't equal 21. So yeah, if there was an easier way, Christina, I would promise that I will show you the easiest ways. Okay, So if there's an easier way out, I'll show you. I like the easy, efficient ways out. And I like the silly stories. So what I've shown you is the absolute easiest way to do this. Okay. And this method, I really do believe that you will come to totally love it. You will love it, Christina. You will love this. Right,
She said
Brandy?
you're a little bit too far, Miss Deborah.
Do what?
Christina said you're going a little bit too far with that now.
Are you okay, Mary, or do you need to see another one? You think you can start it? Brandy, do you feel good enough to start?
Yeah, on this one, but the subtracting, no.
Okay, well, we'll try. Okay. Doris, do you feel okay to start trying these?
Yes.
Okay. Okay. So we had kind of a rough start, but nobody will ever see that video.
Why, what happened to it?
Oh, we don't talk about that kind of stuff.
Oh, okay. Well, I'm going to stay on then.
Okay, you stay on and I'll help you. I know that you have to come on late. Any more questions before I stop the recording? Okie dokie. Well, then you know how much I love y'all. I am glad to be back. We'll talk to you tomorrow. Bye-bye.
Okay, bye.
Okay. You've got 3 more pages. And the last page, we can look at it, but you can try it. It just says, work these with whatever method you want to work them.
Miss Deborah,
Yes.
Miss, you're still recording.
Ah. Huh. Thank you, ma'am.